Hi everyone, in this video I'm going to be going over how to write an inverse function using an original inverse chart, which we call an OI chart for short. In my first example, we're trying to find the inverse function of f of x, where f of x is equal to 5x cubed minus 1 over 2. So the first thing I'm going to do is make my OI chart. Remember, O stands for original and I stands for inverse. So on the left side, I'm going to list the steps in the function that are the original steps. So I need to go ahead and look at my function that's written and figure out what are the steps in this original algorithm that get us from our original number we plug in, x, to our output. So our input to our output. So our input is always x. So I need to focus in on x and figure out what's happening to x in what order. So when I look at x, I can see it's helpful to think about PEMDAS. Okay, so P stands for parentheses, and I don't have any parentheses. E stands for exponent. So when I look at 5x cubed, I'm trying to figure out, am I going to cube x first, or am I going to multiply by 5 first? Well, exponent comes before multiplication. So that means the first thing that's happening to x is it's being cubed. So I'm going to write parentheses cubed as my first step because that's the first thing that's happening to x is it's being cubed. Next, now that I got my exponent, I have that I'm being multiplied by 5. Now I also see us subtracting 1, but subtraction is at the end. So I'm multiplying by 5 next. So times 5 goes next in my chart. Now I'm either subtracting 1 next or dividing by 2. Now even though we don't have parentheses, whenever we have something like 5x cubed minus 1, the whole thing is being divided by 2. That means we can kind of always think of whatever's on top as having its own set of parentheses. I'm always going to finish what's in my numerator before I move on to the division. So that means I am going to subtract 1 next. And then finally, the last step is dividing by 2. So I've listed all of that on my original side. Now, in order to write my inverse steps, I need to go in the reverse order, and I need to do the opposite operation for each step. So that means I'm going to follow my chart from the bottom to the top, and I'm going to find the opposite operation. So we start with divide by 2 because that's at the bottom and we're going in reverse order. So you might be tempted just to write divide by 2, but we forgot. We need to find the opposite operation of dividing by 2. Well, for division, the opposite of dividing is multiplying. So that means my first step for my inverse function is multiplying by 2. Now, the next step when I'm going in my reverse order is minus 1. But remember, we need to find the opposite of subtracting 1. So the opposite operation of subtraction is addition. So I'm adding 1. All right. Now our next step, going up on the original side, is times 5. But we need to do the opposite of multiplying by 5. The opposite operation of multiplication is division. So that means we're going to divide by 5 next. Now we have one more operation. The operation that was originally our first operation is now our last. So we cubed x first. But remember, we need to do the opposite of cubing. So the opposite of cubing is cube rooting. And remember, to show that it's a cube root, you need to have that tiny little 3 next to the root, okay? If you forget that, you're writing a square root. We need to make sure we write a cube root. So now that I've made my inverse steps in order, I can write my function, my inverse function. So remember the notation for your inverse function, our function was called f. To show that it's the inverse of f, we put this little minus 1 above the f, and then we still write the parentheses x. So our original function was called f. This is f inverse of x by putting that little minus 1 there. Now we need to go ahead and build our inverse function by following the inverse steps. Now we already reversed them, so we're just going to follow them in order from the top to the bottom. So we always start by writing x first because these steps are always being done to x in that order. So we're going to start by writing x. Now the first step is multiply by 2. So to multiply x by 2, I just need to go ahead and put a 2 in front of the x. Then it says to add 1. So I need to take this 2x and add 1 to it. Then it says divide by 5. Now you might be thinking, oh, I need to divide by 5. I can just go ahead and do it like that. Nope, that's not quite right. Now I can't just divide by the 2x by 5. I need to divide everything I already have written by 5. So anytime you're following these steps, each next step is happening to everything that you already have written. So I added 1 to the whole 2x. Now I'm dividing the whole thing by 5. So I need to make sure that fraction bar extends all the way under everything I've written. And then finally, I need to take the cube root of what I have here. Now again, don't just take the cube root of the numerator. We need to take the cube root of everything we have. So we need to make sure this cube root is very obviously extending over the entire fraction. And so that's our inverse function. All right, so let's try one more example. We're trying to find the inverse function this time of g of x, which is square root of 7x divided by 2 plus 1. Okay, so once again, I'm going to start by making my OI chart. O stands for original, I stands for inverse, in case you forgot. So first we need to write our original steps. So I'm going to go ahead and focus in on my input, which is x, and figure out what's happening to x and in what order. So remember, PEMDAS can help us. And remember, we talked about how whenever we have something being divided, we can think of the numerator as having little parentheses. So that means we're going to start within those parentheses. Since x is in the numerator, we're going to start with whatever's in the numerator. And in this case, the only thing happening in that little numerator is we're multiplying by 7. So the first thing that happens to x is it's being multiplied by 7. Now, before we get to the square root here, we need to finish everything inside the square root. Remember, whenever we're evaluating something under a root, we evaluate everything inside the root before we actually take the root. So that means before we get to the square root, we're dividing by 2. So divide by 2. Now we've done everything inside the root. That means we can actually take the square root now. And square roots, we don't write a 2 here. Sometimes it's tempting to do that, but you don't need to write a 2, you just leave it blank. That's automatically a square root. And then finally, we are adding 1. That's the very last thing, so we add 1. All right, so to find our inverse, we need to do the reverse and the opposite steps. So I'm going to start at the bottom of my original column and move to the top, and then find the opposite of each operation. So at the very bottom, I have plus 1. So instead of adding 1, I'm going to do the opposite, which is subtract 1. Next, we have the square root. Now, if the opposite of cubing was cube rooting, then the opposite of square rooting is squaring, which just means raising something to the power of 2. Now we have divide by 2 as the next step, but we need to do the opposite of that, which is multiply by 2. And then finally, we have multiplying by 7, and we need to do the opposite of multiplying by 7, which is dividing by 7. So now that we have our inverse steps, we need to follow them top to bottom as we build our function. This time our function was called g, so it's very important to remember the name of this function was g. So to write the inverse of g, we're going to write the g, the little minus 1, and then the parentheses x. So the inverse of g of x. Now we always start by writing x first because that's our input. That's what we're doing all the steps to. So we write our x. Now we follow our steps on the inverse side top to bottom. So I have minus 1 as my first step. So I'm going to go ahead and subtract 1 from x. Then it says to square. So remember, we need to do this step to everything we already have. So that means we need to go ahead and put parentheses around what we have and square it. Next, we're multiplying by 2. So we need to multiply everything by 2, which means we need to put the 2 in front of the parentheses in order to multiply all of it by 2. Next, we need to divide by 7. So remember, we're dividing all of this by 7, so our fraction bar needs to extend all the way across, and then we put the 7 in the denominator. And there we have our inverse of g of x.